We are on What is a Mole, and we're going to hang out with Tyler for 10 minutes. Okay. Oh, and I need to make sure we're not muted. We're not muted. That's good. And we're plugged into sound, so I hope this is going to work. What page are we on? 4.
In this video, we're going to talk about the basics of moles. We're going to learn about what they are, and we're going to talk about some of these important numbers and terms. Now, we're going to start from the very beginning on moles here, so no matter how much you know or how much you don't know about moles, this video will be a great place to start. So what's a mole? I'm not talking about the cute little furry creatures that live underground. I'm talking about the kind of moles that are super important in chemistry. So a mole is a name for a specific number of things. Okay?
I'm going to try and make it just a little bit louder. Let's see if we can do that. No, we're at 100 there. We're at 100 there. I think we're as loud as it'll get.
A mole is kind of like a dozen, right? A dozen is the name for 12 things, or 12 things in a dozen. Now, a mole is like this, but it's way bigger than a dozen. 12 things in a dozen. In a mole, there are 602 hexillion things. This is 602 followed by 21 zeros.
Did you guys get that? 602 followed by 21 zeros. I'm going to give you a second to write that down, maybe even 10 seconds. Yes? Because part of what you're doing is you're internalizing how incredibly big this number is. That's 21 zeros after the 602. So really, we're not doing anything different than we did for the first couple of units. We're going to be doing unit conversions. We're going to be doing scientific notation. We're going to be doing sig figs. The only thing to wrap your head around is that a mole stands for a number, just like a dozen stands for a number. A dozen is 12, but a mole is 602 hexillion. This really big, awkward number. Are we ready? Are we counting our zeros? Okay.
602 hexillion things. So a mole, like a dozen, is a name for a certain number of things. There are 12 things in a dozen. There are 602 hexillion things in a mole. This is a gigantic number. Now, here's one thing that confuses people about moles. They forget that a mole is a name for 602 hexillion things, and they think that a mole is an abbreviation for the word molecule. So many people think this. They see mole and they think, oh, you mean molecule. No. If I write mole, I don't mean molecule. I mean a group of 602 hexillion things, not a molecule. So there are 6.
Okay, so a mole is not a molecule. Okay? Mole is not an abbreviation for molecule, which is why we abbreviate molecule as capital M, capital C. Okay, and we'll go into that in a little bit.
602 hexillion things in a mole. And just like a dozen, we can have a mole of anything, right? So we could have a dozen donuts, which...
Okay, and I'm going to give you another minute to write down 602 with 21 zeros after it, again, after where it says key point. And I know it might seem silly, but you're internalizing this number right now, okay? And if you're getting tired, yeah.
Which would be 12 donuts. Or we could have a mole of donuts, which would be
how many donuts? 602 with 21 zeros. Or 602 hexillion donuts.
602 hexillion donuts. Or hey, we could have jelly beans. A dozen jelly beans would be 12 jelly beans. And a mole of jelly beans would be 602 hexillion jelly beans.
So I'll give you a minute to write down all those zeros. A lot of zeros. And after this, we aren't going to have to write all those zeros anymore. Okay? I promise. Why do we not need to write all those zeros anymore? Because we know a technique for dealing with things that have too many zeros. Scientific notation, yes.
So sometimes people get freaked out about moles, but just remember they're a lot like a dozen. 12 things in a dozen, 602 hexillion things in a mole. You can have a mole of donuts, you can have a mole of jelly beans, a mole of cars, a mole of paper clips, a mole of bouncy balls, just as long as it is 602 hexillion things, you got a mole. Now let's talk a little bit about this actual number, 602 hexillion. This number is often referred to as Avogadro's number.
Okay, this is Avogadro's number. Not avocado's number, although you can make guacamole from an avocado. Yeah? Avogadro.
In honor of the Italian scientist who discovered it. But now, check this out here, right? 602 hexillion. This is a gigantic number. 602 with 21 zeros after it. Think about what a pain it is to deal with this number, right? If you're doing math by hand, you got to write this out and like do your multiplication and division with 21 zeros. Even if you're using a calculator, you got to type in all of these zeros and make sure you have the right amount. And then when you get your answer, you got to go back and count how many zeros your answer has. It's a total pain. So instead of writing out 602 hexillion with all these zeros every time we want to talk about moles, we tend to abbreviate this number. Now, as you may know, when we abbreviate numbers in math and science, we usually use a technique called scientific notation. And here's how we would abbreviate this number using scientific notation. Okay, I got this big number, 602 hexillion. I find out where the decimal place would be. It would be right here. And now I move the decimal place until I have just one digit to the left of it. Okay? And I count the number of spots. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. And now this is my new spot because there is 6, just one digit to the left of it. So I moved my decimal place 23 spots to the left. And that means that in scientific notation, I would rewrite this number as 6.02 times 10 to the 23rd. The 23 comes from the number of spots that I moved it to the left. So 6.02 times 10 to the 23rd is how we often abbreviate this gigantic number, 602 hexillion, when we want to write it out and use it, say, in math problems. Now, this is a convenient way to write this gigantic number in scientific notation, but it's also a terrible way to write it. Because this number, 6.02 times 10 to the 23rd, it looks terrifying, right? It's got this 10 with the exponent, 6.02 times this thing. It's like people see this number and they're like, oh my god, what do I even do with this? Relax. It's okay. 6.02 times 10 to the 23rd might look a little terrifying, but just remember that it is an abbreviation for 602 hexillion, that it is an abbreviation for this very large number here. Every time you see 6.02 times 10 to the 23rd, just remember that it is an abbreviation for 602 hexillion.
602 hexillion. Now, if anyone wants to remember this very easily, you remember how I said your periodic table charges are as easy as 1, 2, 3? Remembering Avogadro's number is almost as easy as 1, 2, 3 because it is 6.02. I will give you that. You just have to memorize that. Okay, 6.02 times, look, 1, 2, 3, 10 to the 23. Ooh. 1, 2, 3. Is good? So you're like, okay, what power was it? 10, which has a 1 in it, to the 23. 1, 2, 3.
Is an abbreviation for 602 hexillion. Okay, so now we've learned what a mole is, how many things are in a mole, and we've learned how we can abbreviate this gigantic number, 602 hexillion. The last thing I want to do is give you a sense of how gigantic this number, 602 hexillion, how gigantic it really is. Okay? So let's think about this mole of jelly beans that we talked about earlier. 602 hexillion jelly beans, which you know now we can abbreviate as 6.02 times 10 to the 23rd jelly beans. These are all just three ways of writing the same number. Okay? If you had 602 hexillion jelly beans, that would be as large as the entire planet Earth. A mole of jelly beans would be as big as the planet Earth. That is crazy. Think about how many jelly beans that is. I mean, really. Think about how many jelly beans it would be if your house were filled with jelly beans. Okay, that would be gigantic. Think about how many jelly beans would be if every building in your town was made only of jelly beans, okay? Like, that would be a ton. Now, imagine how many jelly beans you'd have if the entire Earth were made of nothing but jelly beans. And that is how big a mole of something would be. Now
I want you to think about a tablespoon of water. Can you picture that? Okay, tablespoon. That contains about 6.02 times 10 to the 23 water molecules. So jelly beans takes up the space of the Earth, water molecules takes up a tablespoon because molecules are so incredibly small, which is why we need such an incredibly big number to count them.
We could have also a mole of donuts, which would be 602 hexillion donuts, 6.02 times 10 to the 23rd donuts. If we had this many donuts and we stacked them on top of each other like this, we had 602 hexillion donuts and we kept making the stack. This stack would reach from the Earth to the Sun and back 200 billion times. This stack of donuts would reach from the Earth to the Sun, back and forth 200 billion times. Again, think about how many donuts we would have if we just laid donuts down like this from like your house to your school, right? That would be a ton of donuts. Now imagine going from Earth to the Sun and back 200 billion times. That is how many donuts 602 hexillion donuts is. But now here's the thing, this is really interesting. We're talking here about jelly beans and donuts, But a lot of times in chemistry, we're talking about things that are much smaller. We're talking about atoms. Now, a mole of jelly beans would be as big as the planet Earth. But a mole of atoms is much smaller. Here, in this container, I have just about 1 mole of sulfur atoms. This yellow powder and these yellow chips are made entirely of sulfur atoms. And there are about 602 hexillion sulfur atoms in this little dish here. So think about this, right? Got 602 hexillion sulfur atoms right here. Now, 602 hexillion jelly beans would be the size of the planet Earth. 602 hexillion sulfur atoms can fit in this little dish. This shows us how absolutely tiny a sulfur atom is, how tiny all atoms are compared to a jelly bean. Really, a mole of these is the size of planet Earth, but a mole of these little sulfur atoms can fit in this dish. So when we're dealing with something as tiny as atoms, a mole doesn't actually take up that much space because the things that we're dealing with are so incredibly small that a giant number of them just isn't that big. So just to review what we've talked about, let's go over a few of the key points. So a mole is kind of like a dozen, except there are 12 things in a dozen and 602 hexillion things in a mole. We can write this number in a variety of ways. We can do 602 with 21 zeros after it. We can call it 602 hexillion, or most commonly, we can abbreviate this number in scientific notation as 6.02 times 10 to the 23rd. This number here, 602 hexillion, is often referred to as Avogadro's number. And now finally, at the very end of the lesson, we saw how 602 hexillion is a giant number. 602 hexillion jelly beans would be the size of planet Earth. But atoms are so tiny that a mole of atoms doesn't really take up that much space. So 602 hexillion sulfur atoms, for example, is a pretty manageable size. And that is an introduction to moles.
Okay.
In this video, we're
Question. Do you want another video with Tyler watching how to convert between moles and atoms and molecules? Or would you like me to teach you how to do converting between atoms and molecules? Yeah. Do we care? Tyler? Miss Spence? Tyler? You can have both. We might be able to fit both in. Should we do Tyler and then if we have time, Miss Spence? Okay, cool. So here we go. This is page 6 now. This is 15 minutes. This might be all we get.
We're looking at how to convert back and forth between moles and the number of atoms or molecules that we have. Now, when we do conversions like this, atoms and molecules are sometimes both referred to as particles.
Okay, so you can fill that one in. Atoms and molecules are particles. Hopefully we knew that already.
Particle is just a word for any individual thing.
Don't
So
worry
a
about the
particle
rest of
could
this
be a
yet.
jelly bean, or a coin, or a paper clip, or an atom, or a molecule. So we'll work through problems like this, where we have to go from moles to, say, atoms, or we have to go from atoms and convert back to moles. Okay, so here's our first question. For each one of these problems, I'm going to do it 2 ways. First, I'm going to show you how to think through it in kind of a simple, straightforward way.
So just before we do that, make sure you filled in that a mole is equal to 6 point what? 02 times 10 to the 23.
so you can really understand what you're doing. Then I'm going to show you how to use conversion factors. I think conversion factors don't always make a lot of sense, and I know a lot of students are confused by them, but teachers and textbooks tend to really like conversion factors, so it's important to know how to solve questions like this using conversion factors too. Okay, so how many atoms are in 5.5 moles of atoms? We're talking about moles and atoms here, so let's just refresh our memory about moles, okay? A mole is like a dozen, but there are 12 things in a dozen, and there are 602 hexillion things in a mole. We often abbreviate this super long number with all these zeros, 602 hexillion, as 6.02 times 10 to the 23rd. Moles can be a little bit tricky at first, and so I want to keep talking about the similarity to dozens as we work through this first problem, okay? We want to know how many atoms are in 5.5 moles of atoms.
Just before we carry on, if I said you have 5.5 dozen atoms, how would you find the number of atoms? 5.5 dozen. 5.5 times 12, right? So what are you going to do when you have 5.5 moles of atoms? 5.5 times 6.02 times 10 to the 23. Yeah.
But to get a handle on how to think through this, let's first think about how we would do this kind of problem if we were talking about dozens instead of moles. So what if instead of 5.5 moles, we were talking about 5.5 dozen? Well, this math is probably pretty straightforward. There are 12 things in a dozen, so if we figure out how many atoms are in 5.5 dozen, we take 5.5 and then we multiply it by 12, the number of things in one dozen, and that would tell us how many atoms or how many things are in 5.5 dozen, okay? But we're not talking about dozen here, we're talking about moles instead. So instead of multiplying this by 12, the number of things in a dozen, we're going to take 5.5 and we're going to multiply it by 602 hexillion, the number of things in one mole. Now, this big number here is a real pain in all these zeros, and if you were actually going to do this math, chances are you wouldn't want to use this long version here, you want to use the shorter version in scientific notation. So let's take this big number, 602 hexillion, and write it in the more manageable form of 6.02 times 10 to the 23rd. This is the same number, 602 hexillion. It's just an abbreviated version. Okay, so you've written this out. Chances are you're going to use a calculator, scientific calculator, or graph calculator to solve this problem. So here's how you're going to type it in. 5.5 times 6.02 E23.
Okay, what button do you use for E? Either EXP or EE or times 10 to the whatever? Okay, you remember the one? Don't type times 10. Okay, do not do that. Just type E, whichever version your calculator has, okay?
Yes, E23 is usually how we do exponents in a scientific calculator. The E is 10 to the exponent, and then 23 here is the exponent. Plug this into the calculator, and we're going to get this as our final answer. There are two things that I need to do to this answer. The first thing I need to do is sort of take it out of calculator scientific notation and put it into normal person scientific notation. So I'm going to write 3.311. E24 is 10 to the 24th. Okay, so that's in regular person scientific notation. But the next thing we got to do.
What's the next thing we have to do? Sig figs. How many sig figs should we have? 2.
Is take into account significant figures. Okay, we'll look at the numbers that went into this to figure out how to round it correctly. Okay, there are 2 significant figures in 5.5, and there are 3 significant figures in 6.02. So we're going to round this number to the lower number of significant figures. We're going to round it to 2. Okay, so we're going to take 3, and we're going to take this 3, and then we're going to look at the 1 to figure out whether to round up or keep it the same. It's a 1, it's lower than 5, so we keep it the same. We'll do 3.3 times 10 to the 24th, and what we're solving for here is atoms. This is our final answer. Now, so many people see a a number like this, 3.3 times 10 to the 24th, and they don't think of it as a real number. So please keep in mind that this number is just a shorthand for this super, super long number with all these zeros. This is 3 heptillion, 300 hexillion atoms. Okay, so 3.3.
So 3 heptillion, 300 hexillion atoms. So those are the blanks at the bottom of the page. 3 heptillion, 300 hexillion atoms. Crazy.
3 times 10 to the 24th. It's not some weird Martian number. Keep in mind that it is just a shorthand version of this very long number here. And if for some reason your teacher doesn't let you use a calculator and you have to do this out by hand, I have another video on doing mole calculations by hand instead of a calculator, so you can check
That
it out.
sounds
So,
insane.
anyway,
You will get to use
this
a
is how we
calculator.
do this problem using a sort of simple, straightforward method. We
That's
multiply
crazy talk
5.5
is what that
by the
is.
number of things in one mole, plug it into the calculator, and this is what we get. Now let's look at how we could solve the same problem using conversion factors instead. Okay. In this case, we're going to be starting with this number here, 5.5 moles. 5.5 moles. And now we are going to want to multiply this by a conversion factor that's going to get rid of moles and is going to give us atoms. To write this conversion factor, we're going to think about moles. Let's look at this definition up here. I want to rewrite this just as an equation with an equal sign. Okay? So here we have 1 mole equals this much. I really haven't changed anything. But I put the equal sign in here because we use relationships like this with one thing on either side of the equal sign. We use relationships like this to write conversion.
Right? Because conversion factors, the thing on the top and on the bottom have to be equal to each other. So if we have 1 mole is equal to 6.02 times 10 to the 23 things, we can use that as a conversion factor.
Okay? So here's how we'll take this relationship and write a conversion factor. A conversion factor has both a top and a bottom. And we take something on one side of the equation, 1 mole, and we can put it on, say, top of the conversion factor. And then the thing that's on the other side of the equal sign, put that on the bottom. So I'll do 6.02 times 10 to the 23rd. Things here, we're talking about atoms. And this
Now here I've got a question for you.
is just telling me that in 1 mole, there are 6.
What do you guys think of that conversion, the way it is? What do you think about it? Do you love it? Yeah, the units won't cancel. That is a thumbs down on that one. What does he have to do with that? He has to flip it, okay? And here's one of the things that students do wrong so often. They will write 6.02 times 10 to the 23 moles is equal to 1 atom. Does that sound good to you? That would be like saying 12 dozen is equal to 1 egg. Right? Like that's just, yeah. So watch out for that. I will point it out again and again as we go through this.
0.02 times 10 to the 23rd atoms. But for every equation like this with an equal sign, there are 2 conversion factors that we can write. We can write it like this, or we can flip it. That's cool too. So I could also write 6.02 times 10 to the 23rd atoms on top with 1 mole on the bottom. Now both of these conversion factors are totally valid. Which one do we want to use for this problem? Well, we want to multiply this by a conversion factor that's going to get rid of moles, is going to leave me with atoms. So moles is on top here. I'm going to want to choose the version of this conversion factor that's going to give me moles on the bottom, so they'll cancel out. I'm going to use this one. And then I've got moles on the top here, cancel out. Moles on the bottom, cancel out here. And that's going to leave me with atoms. Okay. What's
So you
the
guys
math
can
on
fill
here?
this in at the bottom
I'm
of
going to
page
do
7.
5.5 times 6.02 times 10 to the 23rd divided by 1. Now you might realize that dividing this number by 1 doesn't really change anything. So all the math we're really doing is just 5.5 times 6.02 times 10 to the 23rd. which is exactly what we did up here. So you could just type this into your calculator and get this as an answer. Or, which would be totally fine, you could decide you want to put this whole conversion factor in, and you type it in like this: 5.5 times, and then parentheses, 6.02 E23 divided by 1. Whichever one you type in, you are going to get the
You do
same
not have
number
to
here,
type divide by 1.
which
That is optional only if you want.
regular person scientific notation is going to look like this. And then we rounded using sig figs to get this number here. Now once again, don't forget that 3.3 times 10 to the 24th is just an abbreviated version of this very long number of atoms. Okay, so that's how we go from moles to say atoms. Now let's look at how to do problems in the other direction, from say atoms or molecules to number of moles. How many moles is 4.6 times 10 to the 24th sulfur atoms? Okay, check out this number. I just want to remind you that this isn't some weird Martian number, that this is just a shorthand abbreviation for this very long number with a whole bunch of zeros. As we did before, instead of jumping right to moles, let's sort of do this common sense approach where we think about what we would do if instead of moles, we were talking about dozen. If we want to know how many dozen this big number were,
How would you do that if you wanted to know how many dozen that is? You would divide by? Divide by how much? 12. Yeah. So if you want to find out how many moles it is, what would you do? Divide by 6.02 times 10 to the 23, yes.
we recognize that there are 12 things in a dozen, and so we would divide this number by 12. 12 things in a dozen. We want to know how many times would 12 go into this number. Okay, so we're going to be dividing by the number of things in a dozen. But as before, we're not talking about dozens, we're talking about moles. So instead of dividing by the number of things in a dozen, we want to find out how many moles is this, so we are going to divide by the number of things in one mole. So we're going to divide by 602 hexillion.
So that little box is for
As
the division
before,
symbol.
you're probably not going to want to use these giant versions of each number with all these zeros. So this is where the scientific notation comes in handy. Let's rewrite this in scientific notation. Okay, we're going to do 4.6 times 10 to the 24th divided by 6.02 times 10 to the 23rd. Put this in the calculator, and you'll want to type it in like this, where we replace the 10 to the 24th with E24, or 10 to the 23rd with E23. Hit return, and we're going to get a number like this.
Okay, I'll give you a second to write that down. Your homework is just going to be to study for your test, okay? Just letting you know.
Now, it's not in scientific notation, so we don't have to worry about that. But we are going to want to round this with significant figures. There are 2 significant figures here, 3 significant figures here, so we're going to round this to 2 significant figures. We're going to take 7 and the 6, look next door to figure out whether we round up or keep the same. It's a 4, so we keep it the same. And we're solving here for moles. So it's going to be 7.6 moles of sulfur atoms are in this super huge number of sulfur atoms. Okay, I'm going to just slip it in right here. And now, let's look at how we use conversion factors to solve this same problem.
I'm
Okay,
going to get through this.
here we're going to
Don't
start
pack up
with
yet.
4.6 times 10
There's like 1 minute left.
atoms. And we want to multiply this by a conversion factor that's going to get rid of atoms and is going to move me to moles.
What unit do you want on the bottom? Atoms. What number goes with atoms? 6.02 times 10 to the 23. What unit goes on top? Moles, what number goes with moles? 1. Study for your test tomorrow. After the test, we'll be doing pages 9 and so on, okay? Yay! Hi, Chloe. How are you? Good.